okay? So again, comparing them to 0 is very helpful because then all we have to worry about is positive or negative. And that means we're worried about where the x-intercepts are because that's what divides having a positive y or a negative y. All right, so we could factor this one. So factors in negative 14 that add to be negative 5. All right, so that would be negative 7 and 2. Okay, so then this, we put this in factored form. We can do that right here. All right, so our x-intercepts, when this equals 0, is going to be when x is 7 and when x is negative 2. So I'm just going to go ahead and draw a number line. I'm going to put dots to represent those x-intercepts. Now this is quadratic. So we have a visual way that can be very helpful. Since we knew it was a positive 1x squared, so this is open up, so we know this graph looks something like this. And I'm not trying to draw the scale at all. All right, we also know the y-intercept is negative 14, so here's our y-intercept somewhere around here, and that would be negative 14. All right, so since we know what the graph looks like, and we're looking for when the y's are less than 0 or equal to, so we're looking for this part of the graph. All right, so your inequality symbol is going to be greater than or equal to negative 2, less than or equal to 7. And I'll just say that. Okay, I'm not going to write that down. So that's, I guess we did that a couple weeks ago. I can't remember. I'd have to look. I know we did it. I know what happened. All right, so now the next one we already have in factored form, which is cool because we don't have to figure out how to factor this polynomial wherever it came from, all right? So we can just get the x-intercepts, right? And this one we can factor again, because this is a difference of 2 squares. We don't have to do that because we're just trying to solve this problem. But if you wanted to, you could make this x plus 4, x minus 4. All right, so our x-intercepts are negative 2, 5, and then plus or minus 4. Don't forget about plus or minus, because when you solve this, you're going to do the square root of 16. And you put this equal to 0. Okay, so then I'm just going to draw a little number line. Make sure I don't do anything stupid. All right, so negative 4. And again, I'm not really trying to draw the scale because I just want to make sure there's enough room to go over using test points. And then after I go over this using test points, I'll point out how you could figure out the leading term and then the end behavior based upon the leading term, and then also the multiplicity, and we'll do that too. But let's just assume we don't do that, all right? So we have no idea what this graph looks like, but we know those are the x-intercepts. And we're looking for the places where we're greater than 0. So we're looking for the parts of the graph where this is above. So in between these x-intercepts, the graph's either going to be above or below. So there's 1, 2, 3, 4, 5 regions where the graph could be above or below. All right, so what do? Well, if we're above or below in this region, any number in this region will cause the value to be either positive, that would mean we're above, or negative. So we can pick any number in each of these regions to substitute for the entire region to find out if this becomes positive or negative, right? And all we care about is positive or negative. We don't actually have to calculate the value. That's the utility of this. Okay, so I'm going to use 6 here, 4.5 here, 0, negative 3, and negative 6. So you just want to pick a number not too close to the other number, so it'll be a little more intuitive. You won't have to do any calculations. Okay, so I'll start over here. So you put negative 6 in to each of these 3 factors, okay? And then just see, is it positive or negative? So negative 6 plus 2 negative, and then this negative 6 minus 5 negative. When you square the -6, it's going to be bigger than 16, so positive. Okay, so you're going to get a negative, negative, positive. All right, so that means the graph is up there. All right, so I'm going to just double check, and I don't want to do anything stupid. Okay, so then just do the same thing. Put each of these test points in, see if you what you get. Positive, 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 negative, negative, positive, whatever it is. All right, so I'm going to hasten this up. Putting -3 in, we're going to get a negative, negative, and now this is going to become negative because -3 squared is 9, which is less than 16. So now we're going to get a negative, negative, negative. So the graph does that. Now again, I'm not trying to draw it to scale. That's not the point here. We just need a replica that's visual for the purposes. When is this above the x-axis? Okay, now 0. So I'm just putting 0 in. All right, so positive, negative, negative. All right, so that means we got a positive, so the graph does this. Now I'm putting 4.5 in, okay? So positive, negative, positive, because 4.5 is bigger than 4. So that'll become bigger than 16, right? So the only one that's negative is this one. All right, and again, the graph does that, okay? So now 6. When you put 6 in, they're all positive. And now we got what we need. So when is this going to be greater than 0? Well, it's going to be greater than 0 between -2 and 4. It's going to be greater than 0 to the left of -4. And it's going to be greater than 0 to the right of 5. Okay, so we got a good bit of an inequality statement we got to make. All right, so first, I'm going to write the inequality symbol that, or the compound inequality that's going to represent between -2 and 4. So -2 greater than equal to, and then 4. And again, because we have the line under the symbol initially, that means we can't equal the x-intercepts because it can't equal 0. Okay, now we got to do the rest of it. Okay, so less than -4, greater than 5. Okay, and then you just put the word or because those are two conditions. Now, saying one thing, some people are persnickety about this. Okay, and that is because some people want to always make this an and. So if you have an or, some people prefer that you separate these two and use all the word ors. Other people, that's not an issue because you can interpret whether this implies an and or. If that's your assumption, then since less than -4 and greater than 5 can't be an and, you have to interpret this as an or. So just throwing that out there because I've seen it both ways. I tend to be on the practical side because my math was through physics in college. But just pointing that out. Now, let's say we wanted to get the leading term. Okay, now the leading term means only the part in each binomial that has the variable. And there's no exponents on the factors, so we don't have to worry about those. But if this exponent on this binomial was a 3, then that x would become cubed. All right, so if we got the leading term, we're going to take the variable part in each of these 3 factors. Okay, and we didn't have exponents on each of the parentheses on the upper right, so we don't have to add exponents here. All right, you multiply that out. Looks like you get, and there's no number, no. Looks like you get x to the 4th. Okay, so that means the left branch is going to go up and the right branch is going to go up. Okay, and then if you went ahead and did factor this one, right, that would be what, x plus 4, x minus 4. Notice now with all the 4 binomial factors, there are no even exponents. So there's no even multiplicity. So once you get the end behavior, you just do the loop these through all. Whereas if this had an exponent of 2 right there, then at -2, you would not cross. You would touch it and bounce. Because on either side of the -2, this is still always going to be positive. It's not going to change the sign. And then notice when we did the test points, every time we went into a new region, one of the signs changed. One and only one sign changed. Every time we went into each region with the test points. All right, that's because as soon as you get greater than -4, as soon as you get greater than -4, this becomes negative. So once you're in a certain region between 4 and -4, that becomes negative. Right, and as soon as you're on the other side of 5, this becomes positive. And, the -2, that changes this sign. So once you're on the other side of -2, then this becomes positive or negative. Okay?